So we're going to have a revision session on this electromagnetic fields. This is targeted for the electrical engineering students who are preparing for the GATE exam, GATE 25. See, in the recent times, if you observe, the very good weightage, the year by year, he is increasing the weightage for this subject. 4 marks. Do you believe? The 4 marks he is asking. Sometimes even touching to the 5 also. Fine. So it's no longer this subject you cannot just ignore here. And the interesting fact about this one is a small subject. The small subject and very good weightage. Generally, in a conventional, the classroom coaching, we're going to spend around some 30 to 35 hours of lecture on this. Small one. And as far as exam point of view, the most of the questions will be from electrostatics and magnetostatics only. The most of the questions will be from these two things only. One question from here and the remaining questions from here. The time varying fields anyhow is a part of your machines. Fine. Small subject, but very good weightage. Very good deal. Yes. And the competitive exams like GATE, you cannot put any subject as a option, isn't it? You need to give you should not have any love and affection towards any subject or any topic for the GATE like exam. You should give the equal priority to all the subjects and all the concepts. Okay, anyhow guys, so this is the syllabus with the vector calculus and coordinate system, electrostatics, magnetostatics, and then time varying fields. Clear guys? So let us, as we already mentioned, it is a revision session. So let us, I'll try to give the maximum possible content in the stipulated time. Clear? We'll touch all the concepts. So let us start with what is called a vector calculus and coordinate system. First, let us start with the coordinate systems. There are 3 coordinates here: Cartesian, cylindrical, and spherical coordinates. For our subject, generally, in other subjects, if you know the concept and if you remember the formula, that is enough. You can apply for your question and do some analysis. Yes, in the question there will be some 2 to 3 concepts will be combined, and that is how the question is formulated, and you're going to test your application skills or analytical skills. Based on the R, you're going to test your memory. Yes, so these are the different dimensions of the questions can be expected in the GATE exam. But as far as this subject is concerned, what happened? As far as this subject is concerned, you should have some extra skill set. The skill set here is you should have some visualization. That is important. If you know the formula and if you know the concept, that is not enough. That is how the nature of the subject is. You cannot expect all the subjects in the same manner. What is the extra skill set required for this subject is a visualization. Suppose if some question is given for you, you must be in a position to draw that one. Then only you will identify some numericals, some parameters, some values. So you can take those parameters, you can take those values and substitute in the formula. And that is how you get the answer. Almost 50% of, for the 50% of the topics, you need a proper visualization. You should know some drawing the coordinate system. Yes, not 50%, I would say 70%. Okay, guys, let us start with the Cartesian coordinate system. How this Cartesian coordinate system is developed? By assuming this unbound 3-dimensional space as a box. If I want to locate some particular point P on the box, I need 3 coordinates. They are x, y, z. So this is x, y, and then z. Remember, here we are using the right-handed coordinate system. X cross y is z. So x cross y is z. Suppose if I move from right hand fingers from x to y, my thumb will be in the z. And what are the limits here? The limits of x, y, z. It is ranging from minus infinity to plus infinity. X, y, z are ranging from minus infinity to plus infinity. Clear, guys? Fine. So x cross y is z and so on. So you need to follow this thing. It is x cap, y cap, z cap. So x cross y is z, y cross z is, and these 3 are orthogonal set. Dot product of these 2 things is 0. Okay. So you can check out here x cross y is z. Clear, friends? Next is the cylindrical coordinate system. Cylindrical coordinate system is defined by taking the Cartesian as a reference. Again, if I want to locate some particular point P on the cylinder, I need 3 coordinates. They are rho, comma, phi, comma, z. So this is x, y, and then z. These are rho, guys. Rho is a radius. If I drop this one onto the xy plane, this is also rho. How much angle it is making with respect to x-axis is phi, and the distance from here to here is a z. Okay, guys. And what are the limits here? The limits is rho is a radius ranging from 0 to infinity. Phi is from 0 to 2 pi. Z is from minus infinity to plus infinity. Here also rho, phi, and then z. These three are orthogonal set. So the rho is radially outwards. Let me use some other color. So the rho is radially outwards. The rho is radially outwards. This is how the rho is. I want to define at this point. Phi is like this, tangent at this point, and z is anyhow in the z direction. Clear, guys? So these are the things. So the rho is perpendicular to phi is perpendicular to the z. Now here I can do what is called a conversions. We are taking the Cartesian coordinate system as a reference to define the cylindrical coordinate system. So even I can do the conversions here. How conversions can be done? The rho is making the phi with the x-axis. So what is the x component? X is equal to rho cos phi. If I resolve other side, it is y is equal to rho sin phi. Z is equal to z. Now I want to do reverse. Rho is equal to square root of x square plus y square. Phi is equal to tan inverse of y by x. Anyhow, z is borrowed from the Cartesian. Z is equal to z. Clear, friends? Okay, guys. Next, spherical coordinate system. The spherical coordinate system, suppose if you assume this unbound three-dimensional space as a sphere, if I want to locate some particular point P on the sphere, I need 3 coordinates. What are they? R, comma, theta, comma, phi. What is this R? R is a radius. What is theta? Angle made with respect to z axis. If I drop this one onto the xy plane, this is a projection. OA is a projection of R. So how much angle it is making? So what is the z component? It is R cos theta. What is this OA? It is R sin theta. How much angle it is making? It is R sin theta. How much angle it is making with respect to x-axis is a phi. Clear, friends? And what are the limits of R? R is ranging from 0 to infinity. Theta is from 0 to phi. Important. Phi is from 0 to 2 pi. Here also R, theta, phi are orthogonal to each other. It is R cap, theta cap, phi cap. R, theta, and then phi. Clear, guys? R, theta, and then phi. So the R is radially outwards, theta is like this, phi is like this. So R is like this, theta is like this, phi is like this. Seeing the star in the sky is a best example for the spherical coordinate system. So how do you see the star in the sky? It is like this. So what is this angle? This angle is theta. And you will just, if you want to see in this portion, you will shift like this. What is this angle? This angle is phi. And you will see like this. This is theta and this is phi. This is theta and this is phi. So like this, in this way it is 360 degrees. And in this day it is 0 to pi. And R is a radius. Clear, guys? So the R is like this, radially outwards. Theta is like this and phi is like this. Clear, guys? Chalo. Now let us do the conversions here. So immediately one can say this R is making the theta with the z axis. So what is the z component? It is z is R cos theta. This R sin theta is making phi with the x axis. So what is the x component? X component is equal to, it is R sin theta cos phi. Now I will resolve other side, it is r sin theta sin phi. Clear guys? Now I want to do reverse. You can check out this one. So the r is equal to square root of x square plus y square plus z square r. Theta, you can check out theta is equal to cos inverse of z by r, where r is this one, and then phi. What is the phi? You can take the ratio of these two things, it is tan inverse of y by x. Clear guys? So this is all about the coordinate system, 3 coordinates here, Cartesian, cylindrical and then spherical coordinate system. Conversions also we have seen. And there is some 2 theorems here, Stokes theorem and then divergence theorem. What are the Stokes theorem will do? Stokes theorem relates closed line integral with the open surface integral. You have to take one precaution when you are using the Stokes theorem. Clear guys? So let us consider the vector field F. When I draw a vector field here, you have to understand that there is a vector field here. So let us consider the closed loop. Okay guys? And I will consider the loop direction in this way. Just example purpose. It can be other way also. It is dl. Inside this one there is an area. So now you need to decide its normal direction. How? You need to put your fingers in the direction of loop. Your thumb will going to show the direction of normal. So this is a normal direction. Clear friends? Now there is a Stokes. Suppose if the loop direction in other way, then the normal is inside. Then what is the Stokes theorem guys? It is closed line integral of f dl, which is equal to surface integral of del cross f dot dA. So this is Stokes theorem, which you must remember. Directly there will be a questions on that, and this Stokes theorem is an integral part of our subject. This Stokes theorem will going to help us in converting the Maxwell's equations from differential form to the integral form and vice versa. The other one is a divergence theorem. What is the divergence theorem will do? Divergence theorem will relate the closed surface integral with the volume integral. Okay friends, so let us take the vector field F. In this region there is a vector field. I'll consider the closed surface, something like a balloon. Let me put some dots here. Why I am putting these dots? To create the feel that it is a balloon, something like a closed surface. Okay. Inside this one there is a volume. On this one there is a surface. It is dA. For the closed surface, normal direction is always outwards. There is no headache of right hand or left hand. Here you need to use the right hand thumb rule. You have to put your fingers in the direction of loop. Your thumb will going to show the direction of normal. Here there is no such thing. And what is the divergence theorem guys? It is closed surface integral of f dot dA is equal to volume integral of divergence of f into dV guys. So this one is a divergence theorem. Now let us have a question here. Given vector v is equal to x cos square y x cap, of course I cap, j cap or k cap, we can also talk in terms of x cap, y cap and j cap. X cos square y I cap plus x square e to the power of z j cap plus z sin square y z cap, and S, the surface of the unit cube with one corner at the origin and edges parallel to the coordinate axis. The value of the integral closed surface integral of v dot ds is, see this nds is nothing but a ds only. Area direction is a normal direction. So what is the integral is asking for? Integral is equal to closed surface integral of v dot ds. Is asking us to perform over the unit cube 1, 1, 1. This is a unit cube guys, right? and this is a closed surface. Normal direction for this one is outwards. So if you go by this closed surface integral, you need to integrate over total 6 faces. So instead of that, you can make use of what is called a this Stokes theorem, divergence theorem, sorry. So in the first step, find out the divergence of V. What is the divergence of V? Differentiation of this one with respect to x, which is cos square y, plus differentiation of this one with respect to y, so which is 0, plus differentiation of this one with respect to z, which is sin square y, which is equal to 1, cos square y plus sin square y. So what is the integral, guys? It is volume integral of divergence of V, which is 1 into dV. So it is volume integral of dV is nothing but a volume. What is the volume of that box? It is 1 into 1 into 1, which is 1 is the answer. Let me turn the page here. Let us have one more question. If A is equal to xy x cap plus x square y cap, then closed line integral of ADL over the path shown figure is. See, he is asking us to perform the closed line integral. Integral of interest is closed line integral of ADL. But if you go by this closed line integral, how many sections you need to integrate? This one, this one, this one, this one. Instead of that, you can make use of the Stokes theorem, which will going to save our time. Okay, guys. And one more thing. This is a x, this is a y. So if I put my fingers x to y, or if I put my fingers in the direction of loop, my thumb is pointing outwards. Outwards means which direction? Z direction. Now one more thing. What is the small piece of area here? It is dx. This one is dy. So what happens to the differential area, which is dx dy z cap? Clear, guys? So this is equal to surface integral of del cross A dot ds or dA, doesn't matter. Let me call this as a differential surface or a differential area. So I am making use of what is called a Stokes theorem. So which is del cross A is equal to determinant of x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z. What is the x component, guys? It is xy. Y component is x square. This is 0. So x cap into this man, 0 minus 0, minus y cap into 0 minus 0, plus z cap into this is, it is 2x, this into this is minus x. Clear, guys? So del cross A is equal to x into z cap. So what is the integral I? It is surface integral of x into z cap dot dx dy z cap. Clear? So which is equal to surface integral of x into dx dy. Separate out the variables. I'll continue here. X into dx dy. So this is x square by 2. X limits are from 1 over root 3 to 2 over root 3. Y is from 1 to 3. 4 by 3 minus 1 by 3. 3 minus 1. So integral I, check out, it is equal to 1. Okay, friends. Let us have standard forms. What does that mean? See here, guys. There are different operators: differential length, differential surface or differential area, differential volume, divergence, curl, gradient, Laplacian operator. Total how many operators are there? 7 operators are there. 7 operators in the 3 coordinates x comma y comma z. Other one is rho comma phi comma z, r comma theta comma phi. See, last year in the year 24, there was a question, 2 marks question on the spherical coordinate system, which is related to the divergence concept. Gauss law for magnetic field. 2 marks if you know the formula. Concept is very simple if you know the formula. Only thing is, we generally usual perception, usual thing is we will focus more on the Cartesian only. But last year there was a question on the spherical coordinate system. There is no other way. You should know all these 7 standard forms. You should know all these 7 operators in the 3 coordinate systems. So 7 operators in the 3 coordinates, 7 into 3, 21 formulas will be there. Remembering the 21 formulas is a very big headache. So instead of that, what we will do, we will going to bring these 7 operators into the 7 standard forms or generic forms. Fine. So by which you can remember the things easily. That will 7 will going to expand over the 21. Fine. And there is a rhythm, there is some logic, there is some scientific approach in remembering those 7 standard forms. Fine. So let me turn the page here. So this box you need to remember the coordinates and scaling factors. For the Cartesian coordinates, the scaling factors are 1, 1, 1. For the cylindrical coordinates, it is 1, rho, 1. For the spherical coordinate, it is 1, r sin theta. Clear, friends? So I'll tell you what actually it is. See, if I want to remember the standard form for the differential length, the differential length standard form is dl is equal to h1 into du u cap plus h2 into dv v cap plus h3 into dw w cap. Clear, guys? Yes, friends, see here. So that means if you want to, this is a generic form or standard form. Suppose if you want to get it for the Cartesian, h1, h2, h3 will be 1, 1, 1. uv, w will be x, y, z. Yes, if you want to get it for the cylindrical, it is 1, rho, 1. It is rho, phi, zen, z. Suppose if you want to get it for spherical coordinate system, it is 1, r sin theta. So the coordinates will be r, theta, phi, and so on. Clear, guys? So you no need to remember the 3 things. Just if you can remember this one, that is easy. Similarly, differential surface beta or differential area. So it is dA is equal to h1 h2 du dv w cap plus h2 h3 uv uw u cap plus h3 h1 dw du v cap. Clear, guys? So there is some rhythm in this equation. What is that rhythm? h1 h2 h2 h3 h3 h4 h3 h1. So accordingly you can modify, you have to expand this one to the Cartesian, cylindrical and spherical. Clear, guys? Next, volume, differential volume. So the dV is equal to h1 h2 h3 du dV dw. Clear, guys? So now you can expand this one for the Cartesian, cylindrical and spherical. Fine. Next, let us finish this one. I want to define what is called a scalar field. F of u comma v comma w, just I will represent it as a f. So the gradient is performed on the scalar field, output is a vector field. So gradient of f is equal to 1 by h1 into dou f by dou u cap plus 1 by h2 into dou f by dou v cap plus 1 by h3 into dou f by dou w cap. Now you can expand this one over the Cartesian, cylindrical and spherical. Clear, guys? Next, divergence and curl. Divergence and curl are performed over the vector field. Divergence is performed over the vector field, output is a scalar field. curl is performed over the vector field, output is a vector field. Clear, guys? So the divergence of F, the standard vector is F is equal to Fu u cap plus Fv v cap plus Fw w cap. So the divergence of F is equal to 1 divided by H1, H2, H3 dou by dou u H2, H3 into Fu plus dou by dou v H1, H3 into Fv plus dou by dou w H1, H2 into Fw. Clear, guys? So H1 is missing, H2 is missing, H3 is missing. So in every formula, every generic form, there is some rhythm. Okay, fine. Then what happens to the curl of F, guys? It is 1 divided by H1, H2, H3. H1 into u cap, H2 into v cap, H3 into w cap. Dou by dou u, dou by dou v, dou by dou w, H1 into Fu, H2 into Fv, H3 into Fw. Clear, guys? Chalo. Next, last operator, Laplacian operator. So I am taking the scalar field F, guys. So let me write down the generic from here. So del square F is equal to 1 divided by H1, H2, H3 dou by dou u H2, H3 divided by H1 dou F by dou u plus dou by dou v H1, H3 divided by H2 dou F by dou v plus dou by dou w H1, H2 divided by H3 dou F by dou w. Clear, guys? So divided by H1, divided by H2, divided by H3. So there is some rhythm in the equation. Clear, guys? So these are the 7 standard forms. You need to practice them. You must know them. Then only these, anyhow, all these 7 standard forms, seven operators here and there, everywhere, we are going to use that one in the electromagnetic theory. Clear, guys? Fine. So you have to remember this table, the coordinates along with the scaling factors, followed by the differential length, differential surface, differential volume, gradient, divergence and curl, Laplacian operator. Fine. Let us take some questions here. You direct question we cannot expect, just for our practice, just I wanted to show you the samples here. That's the reason most of the cases you will be, all these 7 standard forms are associated with the, so this is for EMF, this is for the flux, this is for the volume charge, and this is for the Gauss law, this is for the Ampere's law, this is for the gradient relation, this is for the Poisson's equation. So all these 7 operators will going to help us in understanding the concepts of electromagnetic theory. Clear, friends? Fine. Direct questions, yes, can be expected, but there are less chances. But we'll take some samples here. Yes, guys. See here, let us take some samples here. So the scalar field in certain region is defined as r square sin theta cos phi. The magnitude of the gradient at a point 1 comma pi by 4 comma pi by 4 is numerical answer type question. This is. So what is the scalar field? F is equal to, it is a spherical coordinate system. It is r square sin theta cos phi. So what is the gradient formula in the spherical coordinate system? It is dou F by dou r cap plus 1 by r into dou F by dou theta cap plus 1 by r sin theta dou F by dou phi cap. So what is the differentiation of this one? It is with respect to r, I am directly 2r sin theta cos phi r cap plus 1 by r into, what is the differentiation of this one with respect to theta? It is r square cos theta cos phi theta cap. plus 1 by r sin theta. What is the differentiation of this one with respect to the phi? It is minus r square sin theta sin phi cap. So gradient of f is equal to 2r sin theta cos phi r cap plus r cos theta cos phi theta cap minus r sin phi cap. He is asking at a point at 1 comma pi by 4 comma pi by 4. So this is r theta phi. So what is the gradient of f, guys? 2 into 1 into 1 by root 2 into 1 by root 2 into r cap plus this one 1 into 1 by root 2 into 1 by root 2 into theta cap minus 1 into 1 by root 2 into phi cap. Clear, guys? So what happens to the gradient of f, which is r cap plus 1 by 2 theta cap minus 1 by root 2 phi cap. Clear, guys? So what is this gradient of f? Is asking for the magnitude. Magnitude is equal to square root of 1 plus 1 by 4 plus square of this one is 1 by 2. So this can be written as square root of 1 plus 4 by 4 plus 1 by 4, 1 by 4 plus 2 by 4. So it is square root of 7 by 2. Can anyone tell me what is its value, guys? Root 7 by 2. It is 1.32 is the answer. Am I correct? Okay, friends. Fine. Let us have one more question. Here is a question. Yes, guys. So f of rho comma phi comma z is equal to rho cap plus rho sin square phi cap minus z cap. Which of the following is true? Options are given. Clear, friends? This is in the cylindrical coordinate system. Is asking for the divergence at the 3 points. At phi is equal to 0, at phi is equal to pi by 4 and pi by 2. So what is the divergence of f formula in the cylindrical? 1 by rho into dou by dou rho into f rho plus dou by dou phi into f phi plus dou by dou z into rho into fz. Clear, friends? So it is 1 by rho into dou by dou rho into f rho. What is f rho, guys? The rho component is rho plus dou by dou phi into d phi. It is rho sin square phi. It is rho sin square phi plus dou by dou z into rho into minus z. Clear, friends? So 1 by rho into rho is rho square. Rho square differentiation is 2 rho plus this one is sin square phi. It is rho into sin square is, it is 2 sin phi cos phi. This one it is minus rho. So this is 1 by rho into rho plus rho into 2 sin phi. It is sin 2 phi. So divergence of f 1 plus sin 2 phi. He is asking at the 3 different points, guys. So at phi is equal to 0. So the divergence of f is equal to 1 plus sin 2 into 0, which is 1 plus 0, which is equal to 1. at phi is equal to pi by 4, one more point. So the divergence of f is equal to 1 plus sine 2 into pi by 4, which is 1 plus 1, which is equal to 2. Clear? At phi is equal to pi by 2. So the divergence of f is equal to 1 plus sine 2 into pi by 2. So it is 1 plus 0, which is equal to 1. So you can check out here, option D is the answer. Clear, guys? Let us have one more question here. The magnitude of the curl of a vector field. So this is also in the cylindrical coordinate system is fine. So what is the curl formula? Generally we focus, why I have taken these sample things is just I wanted to show the importance of all those 7 formulas in the 3 coordinate system, Cartesian, cylindrical, and as well as in the spherical coordinate system is also important, guys. Generally we do not give much attention for the cylindrical and spherical, but last year there was a question, you must be careful with that. Okay, guys, chalo. So it's asking us to find out the curl. This is in the cylindrical coordinate system. It is 1 by rho into rho cap, rho into phi cap, z cap, dou by dou phi, dou by dou z, f rho into f phi, fz. So this is having only phi component. So this is 0, this is 1 by rho, this is 0. Clear, guys? So it is 1 by rho into rho cap, rho into phi cap, z cap, dou by dou rho, dou by dou phi, dou by dou z. So this is 0. This is rho is already there in the formula, it is 1, it is 0. Differentiation followed by the constant, which is 0. Yes. So this is 1 by rho into rho cap into this minus 0 minus 0, minus rho into phi cap, this into this 0 minus 0, plus z cap into this into this 0 minus 0. So which is equal to 0. Okay, friends, see here, this is all about the first chapter. Even though this is not mentioned in your syllabus, the vector, actually your syllabus starts with the electrostatics, but without these prerequisites, without these fundamentals, without this foundation, without this understanding, without this mathematics, understanding the electromagnetic theory is merely impossible. Okay, guys, so that is the reason why. So these things you have to focus. Sometimes you can take this as a part of your vector calculus, but the coordinate systems are not discussed in your vector calculus. Only the vector calculus, theorems, line integral, surface integral, volume integral, Stokes theorem, divergence theorem, gradient, isn't it? So these are the things which are discussed. Anyhow, guys, so these are the things need to be focused. What are they? The coordinate system. Yes, you should have a proper visualization of the coordinate system, then only you will understand the question. That is what I was keep on repeating. The extra skill set what one should have to deal with this subject is a visualization. For that you have to have proper understanding, proper visualization of the coordinate systems. Fine. So these are the 3D images will going to help us in understanding the things in a proper way. Here is a thing, these are cylindrical, these are spherical, and conversions also. This is for the spherical coordinates. Stokes theorem, and other one is a divergence theorem. Some sample questions, standard forms, extremely important. You have to remember this form, this box, the coordinates along with the scaling factors, and followed by the differential length, differential surface, differential volume, gradient, curl and divergence, and Laplacian operator. Yes, friends. So these are some of the sample things. Now we will going to start with what is called electrostatics. Concepts are simple. Subject is small but good weightage. Yes, friends. Let us have some 5 minutes break. We'll come back out of the break. After that, we're going to start with this new chapter. Okay, guys, just 5 minutes, just relax. Yes, guys, see here, let us start with the second chapter. Electrostatics. It is a study of charge which is at the rest. Fine. So let us start with the Coulomb's law. Spelling correct, it's not correct. Okay, doesn't matter. So if there are two charges here, the Q1, Q2, what is the force on this one due to this one? Line joining these 2 points. This is a force direction, not like this, not like this, line joining. So it is R12 vector and there is a unit vector here. So this is F12. The force on second one due to first one. So the F12 is given as Q1, Q2 divided by 4 pi epsilon R12 square into R12 cap. Units are newtons. Clear? And what is this epsilon? Epsilon is equal to epsilon naught epsilon r. And what is this R12? It is vector by its magnitude. You can bring this one and substitute there. So it is F12 Q1 Q2 divided by 4 pi epsilon. It is R12 vector by R12 magnitude cube. Okay, guys, this is for the mathematics. Don't think that the force is varying as 1 over the distance cube. It is 1 over the distance square only. Clear, guys? So it is a very simple one. The only thing is you should properly use the vectors. Let us have one question here. 2 point charges Q1 and Q2. See, on the this Coulomb's law also there was a question. Fine, it may be simple one, but there is a question. There was a questions. So 2 point charges Q1 and Q2 are located at 3, 0, 0, 1, 2, 0. Find the relation between Q1 and Q2 such that the x and y components of the total force acting on the test charge. Components of the total force on a test charge Q naught placed at 1, minus 1, 0 are equal. Let me draw some diagram here. There are two charges here. It is Q1 is equal to 3, 0, 0. Q2 is 1, 2, 0. This is Q naught is 1, minus 1, 0. What is the force on this due to this one? Line joining 2 points. So this is F1. What is the force on this due to this one? Line joining 2 points. It is F2. What is the total force? F1 plus F2. You can apply the superposition principle. What is the force here? It is Q1, Q2 divided by 4 pi epsilon R12 square divided into R12 cap. Units are newtons. Clear, guys? Chalo. It is the force on second one due to first one. So you can apply the superposition principle here. Yes? So can I write down directly? F total is equal to, what is the force between these two charges? It is Q1 into Q naught. Q1 into Q naught divided by 4 pi epsilon, vector by its magnitude cube. So unit vector can be written as vector by R12 cap is equal to R12 by R12 magnitude. So vector by its magnitude, that means you can make use of this one. Vector by its magnitude cube. Okay, guys. So it is 1 minus 3. So this point minus this point, it is 1 minus 3 is minus 2 x cap. Minus 1 minus 0, it is minus y cap divided by square root of 2 square plus 1 square, it is square root of 5 cube plus between these two things, guys. So it is Q2 into Q naught divided by 4 pi epsilon 1 minus 1 0 minus 1 minus 2, it is minus 3 y cap. What is the magnitude of this one? Is 3. It is 3 cube. So what it is said in the question, x component is equal to y component. Read out the question. In the total force, x component is equal to y component. What is the x component, guys? This is a x component. This is a y component. This is a y component. I'll equate x component is equal to y component. So it is q1 into q0 divided by 4 pi epsilon. It is minus 2 divided by, this is 5 root 5. X component is equal to y component. This is q1 into q0 divided by 4 pi epsilon minus y divided by 5 root 5 plus q2 into q0 divided by 4 pi epsilon y component, it is minus 1 by 9. Just I am skipping the algebra. You can just cancel out the common things on both sides. So it will become 2 into q1 divided by 5 root 5. It is q by 5 root 5 plus q2 divided by 9. Bring this one here. It is q1 divided by 5 root 5 is equal to q2 by 9. So what is asking for? q1 by q2 is equal to 5 root 5 by 9. Clear, guys? So option A is answer. Simple, guys. The force between the two charges, Coulomb's law. Next, electric field, or it is also called electric field intensity. Suppose if you have a charge q, what is the electric field at certain distance? How it is defined? Suppose if you have a charge q small, the force is like this, the distance between these two things is r, the unit vector is r cap. So how the electric field is defined? It is q divided by 4 pi epsilon r square into r cap. So how it is defined? Force per unit charge, Newton per Coulomb, or the other units are volt per meter. So the force is equal to q into E, guys. Yes, friends? Simple. Mathematically, this is a force, this is a electric field due to the point charge. Mathematically speaking, there is no much difference between the electric field and electric force. Suppose if you want to find out the electric field at some particular point, what you need to do? You have to assume as if there is some, for the positively charged one, electric field lines are outwards, for the negatively charged one, electric field lines are inside. Okay. So if you want to solve one question, you have to assume that as if there is some unit charge. Clear, guys? See here, you can approach this question in two ways. You can use the vectors here. You can have a proper coordinate system. That is what I was saying. Coordinate system is important. This is x, this is y, this is z axis. So how the question, a positive charge q is located at a point 0, 0, 3, and the negative charge of q is located at 0, 0, minus 3. So this is on the z axis. It is plus q 0, 0, 3, and there is a minus q 0, 0, minus 3. He is asking what is the electric field, what is the direction of the electric field at 4, 0, 0, here somewhere here on the x axis. So directly one can decide what is the electric field here. So it is a positively charged one, electric field lines are outwards like this. This is the electric field due to the positive charge. Clear, guys? This is a negatively charged one. What is the electric field? It is towards this. So this is the electric field direction. This is, I will call it as a E minus. The magnitude of this one and magnitude of this one are same. Okay. Then what is the resultant if two vectors are like this? You know the triangular law of addition of vector. If two vectors, equal vectors are there like this, and the resultant will be like this between these two things. So the magnitude of this one and this one are same. Why? Because distance from here to here, here to here, and here to here, everything is same. It is something like a, so the resultant will come out of from the center like this. So in which direction it is? It is in the negative z direction. Negative z direction. Option B is answer. Yes, E total. Or you can go in a conventional way like this without any vector approach. There is a charge q here. I am not drawing any coordinate system. It is at 0, 0, 3. The other one is 0, 0, -3. Is asking what is the direction of the electric field at 4, some rough diagram we have taken. Remember, whenever you find the negative charge, better you put that one in the bracket without any confusion. I'll call this as the first charge, this as the second charge. So what is the electric field here due to this one? Line joining these 2 points. What is the electric field here due to this one? Line joining these 2 points. I am putting this one in the bracket and I am taking it as a positive charge. So take that charge along with the bracket. No confusion. So you must be careful with the negative charges. With the due respect, whenever you find the negative charge or negative current, no confusion, guys. So with the proper due respect, put that one inside the bracket. Take along with the bracket. Khatam. Okay. So what is the electric field, guys? E is equal to Q divided by 4 pi epsilon R square into R cap. This unit vector is vector by its magnitude. It is Q by 4 pi epsilon. Vector by its magnitude cube. So what is this E total here? It is E1 plus E2. Clear? So what is this E1, guys, here? It is between these two things. Electric field here due to this one. You have to assume that as if there is a unit charge here. This minus this, it is Q divided by 4 pi epsilon. Vector by its magnitude cube. 4 minus 0, it is 4x cap. 0 minus 0, 0 minus 3, it is minus 3 z cap. What is the magnitude of this one? Square root of 4 square plus 3 square is square root of 25, it is 5 cube. Plus, with a due respect, take that minus negative charge along with the bracket, which is minus q by 4 pi epsilon. So this point minus this point, it is 4 x cap. 0 minus of minus 3, it is plus 3 z cap, divided by what is the magnitude? Square root of 4 square plus 3 square, it is 25, it is 5 cube. I think from here itself you can decide the answer. So it is minus 3z, here minus, it is minus 4x, plus 4x minus 4x will cancel out, minus 3z. So the resultant is in the negative z direction. But let me elaborate this one. Ultimately, what is required in our exam is the answer, not the solution, isn't it? No need to expand this. Just if you can get the answer from here itself, stop there only. Why unnecessary algebra? Yes, guys. So that is the reason why you have to read the question carefully. Reading the question carefully in the sense you need to read the options also properly. Okay. So sometimes the idea will going to strike from the options. It is 4x cap minus 3z cap. It is minus 4x cap. It is minus 3z cap divided by 125. So the E total is equal to Q divided by 4 pi epsilon. It is minus 6z cap divided by 125. Anyhow, guys, so what is this E total? It is 6q divided by 4 pi epsilon into 125 is minus z cap. Clear, guys? So minus z cap, negative z cap, option B is the answer.